Now let's look at this example. We're integrating a rational function, x cubed plus 4 over x squared plus 3x plus 2, but the degree of the denominator is not larger than the degree of the numerator. So what do? Well, then we're going to use long division to rewrite this rational function so that we can use integration by parts. So what we're going to do is divide x cubed plus 4, and we're going to write it as x cubed plus 0x squared plus 0x plus 4. Divide that by x squared plus 3x plus 2 using polynomial long division. So you could also use synthetic division if that's a technique that you use. But we're going to do this by long division. So the x squared goes into the x cubed x times, so we write an x here, and we have x times x squared plus 3x plus 2 is x cubed plus 3x squared plus 2x. And then just like dividing numbers, we're going to subtract here, and the x cubes will cancel, and we'll have a minus 3x squared minus 2x, and we bring down the 4. Now x squared goes into minus 3x squared minus 3 times, so we have minus 3 here. This gives us minus 3x squared minus 9x minus 6. And then if we subtract, the 3x squareds will cancel, and we'll be left with 7x plus 10. So what does this mean? Well, this means that x cubed plus 4 over x squared plus 3x plus 2 is equivalent to x minus 3 plus our remainder here, 7x plus 10 over x squared plus 3x plus 2. So what we've done here is we've turned this into a polynomial and a rational function where the degree of the denominator is larger than the degree of the numerator, so that we can use integration by partial fractions. So now let's look just at this part right here. How are we going to decompose 7x plus 10 over x squared plus 3x plus 2? Well, this right here is a quadratic, but it can be factored into two linear factors, namely x plus 2 and x plus 1. So that means that our decomposition will be a over x plus 2 and some other constant or some constant b over x plus 1. And now if we put these two terms over a common denominator, which will be x plus 2 times x plus 1, we'll have a times x plus 1 plus b times x plus 2 in the numerator. And now what we see is that we have two rational functions here with the same denominator, so that means their numerators have to also be equal. So 7x plus 10 equals a times x plus 1 plus b times x plus 2. And now the job is to find a and b. Well, if we let x equal -1, that will knock out a. So then we'll have 10 minus 7, or 3, on the left-hand side of the equation, and negative b on the right-hand side of the equation. No. So if we let x equal -1, we'll have 3 on the left-hand side of the equation, and then on the right-hand side of the equation, we'll just have b. So that tells us that b equals 3. If we let x equal -2, then we'll have -4 on the right-hand side of the equation and negative a on the left-hand side of the equation, on the right-hand side of the equation, which then tells us that a has to equal 4. So this means that the original integral that they gave us is the same as integrating x minus 3 plus, and now we had a over x plus 2, where a is 4, and b over x plus 1, where b is 3. And now this is something that we can integrate. So this will give us, well, the antiderivative of x will be 1/2 x squared. The antiderivative of -3 will be -3x. And then we'll have 4 times the natural log of the absolute value of x plus 2 plus 3 times the natural log of the absolute value of x plus 1 plus a constant of integration.